Hi everybody, I'm James Forrester. I work for the Wikimedia Foundation, which is the charity that the computer doesn't like me. It is the charity behind Wikipedia and a lot of other web properties that people have heard of, less so. But we're a charity, we're based in San Francisco, and
I'm Roan Kattouw. I also work at the Wikimedia Foundation, and I am one of the software engineers on the project that we're going to talk about.
So we wanted to talk a bit about VisualEditor, which is a project we've been working on for a while and hopefully interest some of you. So a brief overview, why on earth are we building a visual editor? Well, frankly, the big issue that we are facing on Wikipedia and other Wikimedia properties is that there's been a massive drop-off in the number of users who are editing. Long-term contributors less so, but short-term one-off contributors has fallen quite substantially since about 2007. This is a really major issue because, of course, the people who volunteer to write Wikipedia are the reason Wikipedia grows and the reason Wikipedia is liked. MediaWiki itself is an incredibly rich syntax of symbols and codes that are really hard to understand for a newbie, and actually even for someone like me who's been experiencing it for 11 or 12 years, it's still ridiculously complicated in situations. And we have quite a substantial body of evidence at this point that wikitext actually stops people from contributing, both in terms of scaring away potential new contributors, but also existing contributors find that it's so much effort to edit, why don't I just not bother? And really, frankly, it's not an appropriate way to ask people to contribute content in the 21st century or the 20th century. And it also prevents us from offering other editing tools. So one of the things we'd really like to offer people are things like real-time collaboration. And those are basically impossible if the unit of action on a user differs depending on whether they type 2 or 3 apostrophes. And so you don't know whether you're undoing half of one action or all of another action. So when we built VisualEditor, and when we have been building VisualEditor, I think I should say, flexibility and modularity is a really huge thing for us. Ridiculously modular, possibly, I shouldn't say. And that means not only can you extend VisualEditor for MediaWiki, but you can actually use it on platforms other than MediaWiki. And you can, in your integration, replace a tool or extend a tool or, of course, add a new one. And you can expand it for new content or change how you edit existing content. Another thing that's probably worth saying is that we're Wikipedia, and consequently we need to support about 300 languages, and that number keeps going up, not down. 300 languages doesn't feel ridiculous to us because we're used to 300 languages, but when the next people in the field are about 50 or 60 languages, it turns out that that's a bit unusual. There are some issues related to supporting 300 languages, which we'll cover. So the kind of question is, so what are we actually building? It takes 2 parts. There's a client-side JavaScript browser client-side editor. This uses content editable technology. And this is a standalone product. So it edits HTML, and that's it. Nice and simple. And that means you can integrate it on any platform as long as your clients can run relatively advanced JavaScript. We've also built, obviously, a MediaWiki integration, which actually does a huge amount of specialization. So that has ridiculously complex, unique needs because MediaWiki has generated content. That means that the HTML that you see on the page isn't necessarily generated through HTML bits and bobs, but is pulled in from other sources, generated on the fly, based on a templated transclusion, based on pulling in an image, based on a category, lots of different things. Consequently, trying to build a client-side wikitext editor is something that we put aside, and there's a server-side converter that parses between wikitext and HTML, which we call parsoid. That is a huge other project, and we're not going to talk about that today because that would take 4 or 5 hours, and you've got other things to go to. So in graphical form, you start with wikitext, you go through parsoid out to HTML. It's actually HTML RDFA that's been hinted. You do things in VisualEditor that modify it in some way, and then it comes back out again as HTML RDFA, and you go through parsoid, this time through the serializer path of parsoid, and you save as wikitext. Hey, yeah?
Do you actually lose anything in the whole process of converting to HTML and converting back?
Sure. So the question was, do you lose anything when you convert from wikitext to HTML and back? And the question is, the answer is hopefully not. That's been subject of a huge amount of work. We call loss of the specificity of the wikitext to be dirty diffs, and we try and avoid them. We have a lot of work gone in to reduce the number of those through a lot of hacks combined with cleverness. That's our line. And so things like remembering just how many returns you had before this expression, because between 0 and n is legally allowed, and you want to put out the same number the next time through, so the user doesn't get upset. Because one of the things we don't want to have is that users using VisualEditor interact badly with users who are still using Wikitext, and people kind of antagonize each other. Anyway, so this is the overall system. We're not going to talk about the stuff above the line. That, here be dragons. And in fact, if you were going to do a different integration, you don't need to build your own parsoid saving into Wikitext. Please don't do your own parsoid saving into Wikitext. Instead, you can just do something basic like HTML storage and serve and save what comes from VisualEditor. Alternatively, you can do other things, and we can talk about that later. Anyway, I'm now going to hand over to my illustrious colleague.
So yeah, let's talk about some technical details. So VisualEditor is sort of made up of 3 main layers that manipulate the HTML coming in and going out. And I'm gonna discuss the first 2, and James is gonna discuss the latter. But I'm gonna start with the data model, which is basically VisualEditor's internal representation of the HTML document that it's editing. We can't actually directly use the browser to edit the annotated HTML that we get, mostly because, especially in MediaWiki, but possibly in other cases as well, you might have sections of the document that you cannot allow the user to edit directly because you know there's something weird with them, like they're parameterized, things that are generated from somewhere else, or maybe you don't even know what they are and you're just cordoning them off and quarantining them and going, well, like, we'll preserve this, but the user can't touch this. And we need to represent that as like conceptually as opposed to actual HTML a user can edit. So we built a hopefully reliable conversion from HTML to a conceptual model we can edit, which happens to be a JSON model because we're in JavaScript land. And then we're able to round trip that back to HTML without corrupting it, because one source of dirty diffs that we want to avoid is at the HTML level. VisualEditor itself should edit HTML cleanly. And of course, the other source of dirty diff elimination is in the parsed conversion, where the HTML to wikitext conversion can dirty diff. So there's 2 separate layers of corruption avoidance there. We then have to synchronize the data model with the content-editable view, the rendering. And that's actually bidirectional synchronization, because when something changes in the model, you need to update the view to reflect what happened in the model, but the view is also the user's edit surface. So the user can actually put their cursor in the view and change things, and so the view also needs to be able to tell the model, like, the user just removed this character, please destroy this character in the data model. And because we are not at all ambitious, the data model has also been designed in a way that will hopefully facilitate real-time collaborative editing, kind of Etherpad style rich text editing. So I'll give a quick code example kind of thing. We get something like a paragraph tag with hi in it, and we convert that to a JSON array. The whole thing is one big array, and it's all flattened out, where it basically looks like an HTML token stream, where there's an open paragraph thing, the H, the I, and then a closed paragraph thing. The difference between this and a straight up HTML token stream is that you can have entire HTML subtrees that are just compacted into one empty node. Like, this is a thing and we don't know what it is. Let's just make that one thing and let's not have things inside that because we don't understand it. This allows us to, because it's flattened out, it's not a tree, you can do diff patch kind of things on this, which is useful because you can use those transactions to implement undo and redo really easily. And you also kind of need them for collaborative editing because all these libraries that facilitate collaboration want a diff patch kind of thing to happen. So when we deal with input, next slide, James mentioned we take HTML annotated with RDFA. Our use of RDFA is actually very lightweight. We only use it for types. So you might have you might have a definition for, in MediaWiki, you have a thing called a reference. And the definition will say, I am looking for something that has a type MW extension ref. And so we look for nodes that have type of set to that. And we don't really care about anything else. We don't care what kind of tag it is. And then additionally, in the case of MediaWiki, we have a data MW attribute that contains a JSON blob with information that we extract and modify and put back. But that is an implementation detail on the side of the reference. The matching logic only cares about the type of. And then there's other HTML around there, but we don't really care. It's a span in this case. It contains a link. It doesn't really matter. So the way that you actually implement matching logic is very easy, actually. There's a nice API for this, which I should really document at some point. So MW reference node in this case is a class that recognizes a reference. And we say we don't care what the tag name is, so match tag names is null, which means any. And we do care about the type. The RDFA types, which is an array, you can specify multiple, that we recognize are MW extension ref. And then you have to implement some more functions that say that, like, when the matcher has found something that matches that, what should happen to it, what should the linear model, the JSON structure look like, how do we convert the JSON structure back to HTML, but that's all. This is the basic API for saying I want only this. So, as James said, next slide, there are some problems when you do language support. Now, I'm going to follow the lead of some other presenters at this conference and not swear, and instead just remain silent when I would really like to swear. So even in the data model level, we already have challenges when this happens. Because, as I said earlier, data model stores text as an array of characters. The H and the I in the example were separate array elements. But what's a character? So a reasonable definition of character that we started with, basically because it's a native language definition of a character, and that's what you get when you're lazy in JavaScript, is a Unicode code point. At some point, we figured that something called grapheme clusters might be a nice definition of a character. And so to give you a quick example, there are characters in cases in Unicode where you can have one visual character that's composed of multiple code points. For instance, this N with a tilde on top of it is really an N followed by a combining accent mark that puts a tilde on it. And you can actually have multiple combining accent marks piling onto the same character. And so there's 3 code points. So if you represent it as code units, it would take up 3 things in the data model. But if you represent it as grapheme clusters, it's 2. Now, the reason we thought that the latter would be better was because you can't actually put your cursor in between the N and the tilde. Like, that doesn't visually work at all, and it shouldn't be allowed. And we do use some of this stuff for cursoring and stuff, so we were like, OK, there's a Unicode spec that tells you exactly how to cut this up and combine things into clusters, so let's implement the spec and it'll all be fine, right? Nope. It doesn't work at all, because different operating systems, different browsers, and different fonts have their own opinions of how things should be grouped into clusters and where the cursor can go. Think about how evil this is for a second. Your font influences what your cursor can do. Of course, the font in HTML depends on the context, because you might wrap something in a div that has a font family style rule. So you can't do this in the data model. The whole thing falls apart, and we went back to GTF code units. There are a couple more general issues that I'll just list briefly. One thing that's always fun is supplementary characters. These are characters outside of the basic multilingual plane. This character here is the Chinese character for, the Cantonese character, sorry, for elevator, which is not actually, you would expect this to be used on signage in places like Hong Kong where they speak Cantonese, but it's not, presumably because with most PCs you cannot actually print this character because it's outside of the BMP. So it's hard to use technology to make signage that incorporates this character, and so they use the old-fashioned word for elevator instead. Another fun one is the grapheme cluster thing that I just mentioned rears its head again in Indic languages like Malayalam, where if you have certain characters that follow each other, they might be visually combined into one character, and then when you press backspace, it sort of like unwinds and picks the character back apart, which is really confusing if you don't speak the language, and it's also really confusing if you're trying to determine what legal cursor positions are. Another fun one that I touched upon earlier is combining accents. That C is actually 3 Unicode code points. It's a C followed by a backtick that goes on top of the C, followed by a cilia that goes underneath the C, and you can actually pile on as many as you want. It turned out earlier this year there's some interesting bugs in iOS's and OS X's rendering library that allow you to crash iOS devices with this kind of stuff. You may have heard about it. The last thing that we have fun issues with is bidirectional text. This is Hebrew text with numbers. Hebrew is written from right to left, but numbers in Hebrew are written from left to right. And of course, English is also written from left to right. So if you're mixing Hebrew and English in the same sentence, you have mixed directionality text. At this point, different native environments start having interesting different opinions about what should happen when you press the right arrow key. Because that might mean I want to go visually right, or I want to go conceptually forward in the text, which might be left or might be right depending on where you are and what happens in the boundaries. Fun.
What about the other interesting Unicode bit with combining characters, like double S in German becoming the single double S transform?
So the question was, what about other Unicode combining characters like double S into a single?
Are you referring to the phenomenon where in some environments, if you type SS, it'll magically turn into the beta-like character? That is actually part of my next bullet point. On the general category of input method editors, where there is much more swearing ahead, but that's in the next section.
There's no swearing ahead.
There is much more silent swearing ahead, yes. Which is in the next section, which is going to be about the view layer, which we call the content-editable layer. And the reason we call it that is content-editable is a browser technology. And of course, like all good browser technologies, it started as a completely unstandardized thing that a browser vendor just decided to do. And it basically allows you to put an attribute on a div or an iframe or whatever and say, this should be editable. And the browser will put a cursor there and let the user edit the HTML, and you can use JavaScript to reach in there and put things there or read things out of there. And so this sounds great. If you're building an HTML editor for the web, it sounds like this is exactly what you want and you're done, right? Not really, because HTML in the browser, let's use advanced 3 here, has the propensity to completely destroy your HTML and make it unrecognizable as soon as the user does anything interesting, like press enter. In fact, the proposed spec that was written to cover this technology that really just describes what browsers do rather than try to be normative, has 7 pages on what should happen when the user presses enter. If you're using Firefox, you will see lots of BR tags all over the place, even if you don't want them. If you're using Chrome, you might not see them. Horrible things happen. However, there are some advantages to using native technology, which is you get native things. Like you get native text insertion. So if you're on an Android, swipe works. Like I can use swipe in VisualEditor on my Android phone. You can use input methods, more about those later. You have native spell check, so you can right-click on a word and correct the spelling of it. You can't do this, you can actually do this in Google Docs. In Google Docs, they have their own fake editor where everything is completely fake and the cursor is like a little div that's animated to blink. They had to implement their own spell check library because users expect spell check and you can't use the native functionality if the browser doesn't believe there's an editable surface there. You get native selection and cursor behavior, which means you can, for a lot of these problems of I have mixed Hebrew and English text, what should happen when I press the right arrow key, you can outsource those problems to the browser and forget about them for the most part. And you, when you're editing HTML, you want the rendering, you want it to be true WYSIWYG, right? You want the rendering to look the way the browser is going to render it. Well, guess what? The browser is already rendering it in almost the same context that it's going to end up in, so you get that for free. One of the things that we found when we used content-editable, go to the next slide, is that you need to keep it on a leash a bit sometimes. So we came up with a technique called programmatic cursor handling, and we do programmatic handling for a number of other things, but cursor handling is the best example. Which basically you intercept the browser native cursor handling by intercepting events like the user pressed the left arrow key. Then in order to prevent the cursor from entering protected elements, you possibly prevent the browser from doing what it wants to do and instead handle the event yourself and figure out what should happen yourself and do it and don't let the browser do things. This is actually how we started working with content-editable. We were really mistrusting of it. And we said, you're allowed to draw a cursor, and if you try to do anything else, we will stop you and do it ourselves. It turns out that with language support, this doesn't really work. But our main interests are in preventing the cursor from ending up somewhere where it shouldn't be, because we have protected elements, we have cordoned off areas that are not editable. And if you press backspace or delete, that is notoriously variable between browsers if you have anything other than simple text in the same paragraph selected. So if the user is trying to do an interesting deletion, then we prevent the browser from doing what it's going to do and do it ourselves. Now, we thought that keeping very tight control would allow us to have a very uniform user experience and prevent all sorts of stupid browser bugs. Unfortunately, internationalization. You can't do this because you don't know what the native environment is going to do with interesting language problems. You don't know what the local font is. You don't know what the font's opinion of cursor segmentation is. So for the most part, we're getting rid of this approach and instead going to a observe fix-up pattern where we observe that the browser is going to do something interesting, let the native action happen, and then afterwards decide whether we thought that the native action was reasonable and if not, correct it anyway, rather than trying to prevent the bad thing from happening in the first place, we just fix it up after, if necessary. Now, the real source of science swearing here, as promised, is input method editors. So there are lots of languages that you need input method editors for. They're mostly from East Asia and India. In East Asia, you have lots of languages with interesting, very, very, very large alphabets, such as Chinese languages, which have thousands of characters, and you can't have a keyboard this big, so you need to come up with some way of typing those on a standard keyboard. And Indic languages use alphabets that are nothing like a Latin one and tend to also use a Latin keyboard where there are they're basically a software that allows you to type in Latin and it gets converted to your target language somehow. So the main problem with IMEs is that, for us, is that each IME has its own unique special snowflake way of changing the content in the contenteditable surface and emitting events that tell you what happened. These event patterns can differ by operating system and by browser quite a lot. They can also differ by minor version of the IME implementation. So we built a event sniffing framework where we let people type their names in their language into IMEs and log all the event traces that happened, and then play those event traces back against our test suite, against our code in the test suite to assert that our code actually does something reasonable and doesn't get horribly confused by the IME pretending that it opened and closed several times in the same millisecond. So I think we probably have time for this to do a really quick demo of what an IME looks like. I don't think James Computer has any native ones installed, but Google Translate has some JavaScript-based ones. So if you choose that one, actually you need to enable it. You need to click the button now. There you go. And now if you start typing, you will see that every second key press, roughly, except if you do something with SH, you will get a character. So you get partial characters that represent as Latin text, and then when you finish a character combination that is interpreted as a Japanese character, it turns into a Japanese character. And presumably if you pressed enter, it will now be inserted. This IME is actually fairly special in that it keeps what's called the candidate text in a special area, and it doesn't insert into the text box. Most operating system IMEs write directly into the text box, and the character might change as you're typing it. And the way that it tries to notify JS about what's happening there is one of the main problems. If you go to Chinese, you will see a slightly different thing, where if you type more letters, you get all sorts of alternatives because Chinese has, lots of different characters that are pronounced the same but have different meanings. And so you potentially need to choose from dozens of alternatives. And then the main way that you work in these ones is you type some text and you choose an alternative by pressing 1, 2, 3, or 4, and then that gets inserted. Which means that you might have partial text written into your editor, and that text needs to be deleted and reinserted again when it changes, and you get all sorts of event fun. OK, let's go back to the presentation. Another core component of our view layer is, as I described, there's bidirectionality going on where a view is also the input. So we have something called the service observer that polls the editable DOM for changes that happens and notifies the model. Now, of course, we also listen to keyboard events and know that the text is going to change when the user types a character. But there are lots of things that you can do that don't actually cause events to be emitted. Like if you right-click on a word and use spell check to change it, depending on the browser, you will get 1 or 0 events that are emitted. Now, there is a native technology in the works that addresses exactly this problem. It's called Mutation Observer. When we implemented this software, Mutation Observer was just new, and the old technology was just being thrown away because it was horrible, and people realized it made a terrible mistake. So this area wasn't exactly stable when we started implementing this. And in the future, we intend to look at Mutation Observer and possibly actually use it when it's in a state where we want to bother with it. Then, once you've found a change in a DOM and updated the model is going to want to update the view, because it's what happens, right? You change the model, then the model is going to emit an event to the view, and the view is going to re-render. You only want to re-render if really necessary. One is for performance reasons. If the user just typed a character, the native browser implementation probably does the right thing if you just type hello. Like if they press enter, sure, it might screw up in all sorts of ways, but for simple things, it's probably right. And if you re-render on every key press, and typing fast is going to be visibly slow. But also, this is where input methods come back. Anytime you touch the DOM around where someone is working with an input method editor, the input method editor will close in response to this. Which means that if you have a loop that runs every 100 or 200 milliseconds and does something that closes the IME, then if the user is typing quickly, they'll type a little bit, the IME will get closed, they'll still continue typing, so we'll open up again. And you get really fun bugs with characters being inserted out of order because the cursor position moves around, and you get all sorts of horrible nightmares. So you want to avoid re-rendering at high cost, because anytime you re-render, you are screwing over anyone that's using an IME. So we tend to only re-render when we know that either there can't be an IME open, or that if there was one open, it was already going to close. All right.
So now it's my turn. So I'm going to talk very briefly about editing tools, because actually they're the kind of thing people expect from the editor, but in many ways they're the least work, and so there's the least to talk about them. So actual rich editing of stuff, ooh. So in VisualEditor, we roughly split into two kinds of things you edit. You edit text formatting, so we call these annotations. So these are things like bold or italics or strike through or underline or all that stuff. Also things like link or color or language, things that have some level of data. For things that have more complex data, we actually have different ways of editing rather than just toggling on and off. And then there's generated content. So these are the things where VisualEditor really has to work hard because of MediaWiki's specialness. References, templates, metadata, transcluded items, all those things. And we think this makes VisualEditor unique. Having said this aloud, of course, this means 3 people are going to show me better ways of doing it that already exist. So very quickly, in terms of user experience, you get simple toolbar buttons. So, on, off, that kind of thing. So you get bold and italic, clear the formatting. There's also more complex ones like enlist, unlist, or indent or outdent. Then there are dialogue types. So these are complex, heavyweight things that users want to do. And we've built a bunch of these. There's more to come because, yay, MediaWiki has quite a lot of extensions. So for complex items, you have a big dialogue like this with tabbed options potentially. So this is a transclusion. Don't ask why it's called transclusion, not template. Believe me, I want to kill myself. There's also media item, there's reference, there's page metadata, there's, oh heavens, how many of these are there? And then there are, what we developed is a more lightweight kind of tool called an inspector. This is almost like a semi-dialogue, but it's inside the editing surface rather than taking you out of it. And the idea here is, in the middle of typing, you really don't want to switch focus into some big dialogue where you need the mouse. So instead, you get a nice big picture box underneath what you're doing. You insert it, press return, and keep on typing, never having touched the mouse. So this is the one for inserting a link in MediaWiki, although there's an existing link equivalent in non-MediaWiki. Obviously, also language, as I said, formulae. So we have a tech-based, LaTeX-based math equation editor. This is an inspector rather than taking you into a dialogue, because generally you just want to say x to the 3 equals 27 or something like that. And then something like a color picker, something lightweight, might also be like that. Anyway, now less talking, more demoing. So here's one I prepared earlier, carefully craning my neck so I can't see what I'm doing. So this is a live website, and which means it's consequently going to die right when I press the button. So I click edit, and bing, we're now in VisualEditor in a resolution that's a little too low. So do that. But yay. So you can click on interactive elements and get a dialogue, or you can just click in the text and go edit it. This is a link. Oh look, there's a link. You can edit it. Things like that. I could spend 45 minutes, an hour just demonstrating how to use VisualEditor. I'm not going to do that. If you want to, I'd be deliriously happy to talk to you in lunch break. but I just thought, rather than say, hey, we built this stuff and make it sound like vaporware, we should actually show it running in production. Then, finally, yeah, why are we here? Why are we telling you? Patches welcome. Is the brief way of saying that. So VisualEditor is new. We've been working on it for 2.5, 3 years now. Yay. It's in production on Wikipedia. Not all Wikipedias have it out for all users. It's opt-in on a few, like English and German. But if you speak French or Italian or Spanish, those have it opt-in. So opt-out. Never mind. It's available. So you can add new functionality if you're interested in VisualEditor or using something like VisualEditor. That can be for standalone or for MediaWiki itself. Content types, new ways of editing them. So something like, I want to be able to edit an image map. We don't currently provide a way to do that at all. Or you may think that the way that we allow people to edit templates is overly complex and you could build a much simpler one, which is awesome. There's also loads of core functionality that's lying around if someone would be interested in working on it. So we worked with Tow Truck, which is now called Together.js because Mozilla love renaming things. And so that's a real-time collaboration back-end system. We played around with that a bit. It looked really interesting. We haven't actually finished anything with it. That sounds like something that could be cool. Then there's the kind of undiscovered country part of, hey, you know, VisualEditor definitely, probably, maybe works as an integration on a totally different platform. If you want to integrate it with WordPress or Drupal or insert random CMS of your choice, that would be awesome. However, there may be bugs, there are definitely holes, and I'm certain there are really big, stupid things we failed to decide. Sorry. Of course, we're really keen to help if you're interested. We're actually also really keen to help if you're not interested, but that's less interesting to say. So we're really keen to help if anyone's interested. And that pretty much brings us to the end. So questions? Ooh, lots.
Ooh,
yes.
Lots, okay.
So today you're not looking at like if I'm to deploy it in an existing web app that is using some CK editor that I could conceivably run into some hassles.
It would be a light.
The
question was if I were to try and drop VisualEditor into a CK editor situation, would I have some hassles? Almost certainly. We don't think there are any hassles, but we know that we've thought there weren't any hassles with other things we've done before and run into issues. So I would definitely say we'd be incredibly happy to help you do that. And the first person gets much more help from us than the second by very nature. Yeah, there are probably some issues, he says. What we've done is amazing and awesome, and definitely there are no issues. But yeah.
Because, sorry, go ahead.
Is it possible, could you ballpark an amount of time you thought it might take?
So the question was, could we ballpark an amount of time that it might take? If you're in a, so it depends a lot on what your storage backend is and what kind of types of content that you have that might not be done in MediaWiki. So for instance, if you're using CK Editor in, for instance, like a kind of WordPress situation where what you have is basically kind of almost HTML, but there are a couple shortcodes here and there, you would have to write an equivalent of parseroid for that language, which need not be very complex if your language is not very complex. But if you're trying to integrate it with storage that is not wikitext or HTML, you're going to have to write your own HTML to that and back translator. And depending on how complex that is, it may take you years, and it may be rocket science, like in the case of parseroid, or it may take you an afternoon. I'm also happy that you brought up CK Editor because what I think is one of the sort of accidental design decisions that we made 2 years ago that I think turns out to have been a really good decision is the fact that we can work around content that we don't recognize. And if you use CK Editor, you're probably familiar with the phenomenon where it goes, sorry, I don't know what this is, please use the source editor, bye. And we decided that was an unacceptable user experience, and so that's why we built the what we call alienation, because the class is called alien node because we like our class names, which, as far as we know, is a reasonably unique feature in editor.
Two smallish questions. License, and it looks very bootstrappy. Please tell me that CSS is not hard to change.
So the two questions were what license is it under, to which the answer is MIT. And the second question was, it looks bootstrappy. It's not bootstrappy.
It's not bootstrap.
It's not bootstrap at all. We wrote our own framework because, you know, that's what people do.
It turns out that people on the web don't really understand how iframes work, and UI frameworks definitely don't understand how iframes work. And for the inspector widget that we showed you, where you can add in the link in line, you need to have two selections active simultaneously. You have the link that's selected in the main view, but you also have a selection inside of the link target editor. And in HTML, the only way you can have two selections is having two separate HTML documents, and so you need to put one of them in an iframe. And that means that that unless you have all lowercase class names, you start having bugs in Chrome with things not being styled correctly. And so we decided that we should have a UI library that is one, object-oriented, and two, natively supports embedding anything in any sort of iframe ever. And so we wrote one. It wasn't originally written as a UI framework. It was originally just our UI classes, but then late this past year, we decided that it started looking kind of like a UI framework, so we probably should actually make it one. And we're hoping to convince other people that, at least within MediaWiki, this should be the framework of choice for doing UI and JavaScript.
And
yeah.
Just to sort of clarify that, how much more than just the editor does that sort of have? Because I'm sick and tired of taking out of other people's things to get.
Oh, so the question was how much more than just the editor does that? I think that is the UI framework. Oh, this is have. It has generic UI widgets. It does not have things like date pickers or color pickers because we haven't had the need to have date pickers or color pickers. So it is a reflection of what we have tended to need. We've written things as we needed them, but we've taken pains to ensure that everything is generic and universally embeddable, because it turns out it's actually useful to the future you of next year when you want to reuse something in a completely different context.
But if you want an OO thing that will give you a grid layout with buttons, checkboxes, yeah, we built that. Yeah,
we have classes as low levels, things like grid layout. As for styling it, there is default styling, you can theme it. Brianna.
Could you go back to the dialogue thing? So that looks like that's a really beefed up way of editing tables. Is that more or less right?
That is actually a template.
This is a template. So,
can you go back to, can you do the demo?
Yep, sure.
Oh, yeah, we can show you the real one, yeah.
All
That
right.
will,
If I can find it
there
now.
we go, yeah.
So yeah, this is a transclusion with a series of parameters indexed on the left-hand side, for you. Parameters shown with description on the right-hand side. This is a little clunky, and it's one of the things we're working on making.
Serious, that is amazing.
Yeah,
I know how to add templates, and that is amazing.
So the fun problem is that although that looks like nice little text boxes, those are actually arbitrary wikitext document boxes, because yay MediaWiki. So you theoretically could put a couple of, certainly a couple of 100 kilobytes worth of wikitext into one of those boxes, and that would be bad. And we don't currently have inception of templates, so we don't currently parse the parameter values as valid HTML documents, because occasionally the value is *x, because you know that the thing just before the start of your parameter is 2 apostrophes and you want it to be bold rather than italics. And so consequently, it's not just that the document fragment you're giving isn't valid HTML, but it is even valid wikitext. It just happens to get interpreted as such in some circumstances. And this is why we want to kill people. But thankfully, we live in San Francisco where there are really strict gun laws, so that's not a problem.
People also tend to like writing templates that either take or produce output, things like a single closed div tag. Where is the open div tag? It's generated by some other template. These are really interesting problems that this is why Parsoid is rocket science, basically.
Yeah, we feel very sorry for the guys who work on Parsoid, and they feel very sorry for themselves too. There is.
Question was, is there nice table editing?
So there was that's a good question. I will.
It depends on what you mean by
scroll
nice.
down to a table, and I will edit it. So you can just edit contents of a table relatively easily. You can also, and by the way, these are just parameters. These are just templates that just happen to sit there, and I can
have no parameters.
I can copy that and paste it a few times. if that's what you want to do. I don't know why you'd want to do that particular, but that might be an image, that might be status object, whatever.
If you wanted to add
a new row.
So
Yeah.
if you want to add a new row, all you have to do is this.
The technical answer is that we don't have structural editing of tables implemented as such. However, it turns out that this is something that the engineers didn't foresee and that James discovered on his own, is that you can actually abuse the abridged copy-paste feature to do this kind of thing.
But apparently not with my net rotated through 180 degrees, sorry.
Yeah.
Because you can rich copy a cell and that will just get expanded as a table. Yay, you've got structural editing of tables. But please don't do that. We're going to build a proper editor for tables as soon as we can find a table editor concept that doesn't suck. Anybody who has found one, we've looked at 35 and they're all horrible. And we now need to decide. Word 2012 has a good one. Ooh.
Yeah.
Okay, I need to pay Microsoft some money and look at their latest version. Sounds good.
Yes.
Sorry, yeah, question.
Given you have a UI framework, what's the payload?
So the question was what the payload was.
The question is, what is the payload? I forget what the size of the whole editor is. Is it
640, 650?
640, 650K gzips?
Yeah.
Yeah, because I think it was like just over a meg on gzips. It is a fairly large code base. You possibly don't need all of it depending on what you're doing, except if you're us, then you do actually need all of it. We have engineered the MediaWiki integration such that on viewing a page that you're not necessarily going to edit, the payload is like 4K. Once you click edit, you get the other 600-ish ballpark
I can't remember
kilobytes.
exactly the numbers for the payload for just VisualEditor with none of the MediaWiki stuff. I think it's around 300K.
This is all gzips minified.
Yeah, gzip
because that's what you're going to do.
And
Yes.
gzip minifies correctly and doesn't want to suck down extra depths like Ajax.
Oh, no, we, so he, in the last time he came to LCA, presented about Resource Loader, which is our back-end minifier system that definitely wouldn't allow anything like that.
In Battle.rat 2 years ago, I spoke about a framework that I and someone else have written that does minification and all that kind of stuff for you. If you don't have MediaWiki, then you don't have it. We also kind of need to decouple that. We've meant to do that 2 years ago and sort of forgot about it. If you have anything that does minification, or like it works with fairly standard tools, like it's our code passes JS hint with a bunch of configuration options there in the repo, like it minifies correctly, it does. Like it is, if you have some reasonably sane standards compliant embedding framework that means that you're not including every file separately, then it should just work. Yes, front here.
If you're running your own vertical install of MediaWiki, can you get this editor in your own MediaWiki?
So the question was, if you're running your own MediaWiki install, can you get this editor? The answer is yes, mostly. You will have to run a fairly recent version of MediaWiki. We try to make that not be defined as you have to run last week's version that we only just deployed to Wikipedia. But I think right now we depend on...
Our latest dependency is 123.wf2, so that is...
that is like 4 weeks...
Leading edge alpha 2 when we cut 123, so we should backport that. 122 is about to come out, just came out, and we have very slight incompatibility with 122. But
which we should just fix, yeah.
However, you do have to run... It's in the pipeline, yeah, definitely. And actually, one of the things we want to do is backport a lot of the core changes that MediaWiki has had. Most of the reasons we have incompatibility is because we're changing MediaWiki as we go to fix APIs that are broken, thanks to our previous talk for reminding us of how good APIs shouldn't break. So we're looking at backporting a few of those, and hopefully to long-term support versions.
Safe trunk?
Master will always work,
yeah. We'll work with master.
Master of MediaWiki core will work with master of VisualEditor.
And Parsoid.
There aren't any release and master of Parsoid. There aren't any release versions of VisualEditor right now. I think we might have a thing somewhere hiding in a corner somewhere that is supposedly compatible with MediaWiki 122. If we don't already have that, we should build it. But yeah, if you're willing to run master, then things will work.
Just to sort of follow from like what do you have to try and run this? It's like
If you want to be reasonably sure that things run, we actually the Wikimedia Foundation actually publishes as branches in the main repositories the versions that they run on the cluster. which get updated, like the number advances every week. But if you run basically any versions of those, even if we did production hotfixes, those actually go via those branches as well. So at any given time, you can actually download and run what we ran during a given week.
Although, don't do that this morning because we broke MediaWiki.org briefly. Oops.
But we fixed that.
But we fixed it as well. That was a good thing to wake up to at 5:30 this morning.
Yeah.
Oh well. Anyway, I think we're out of time.
We have 1 more minute.
Okay, we have 30 seconds.
I'm just thinking about, it seems there's still some problems when some people are editing in text and some are in VisualEditor. If all your users are in VisualEditor, is that pretty good?
So the question was, do you have interaction difficulties for users split between wikitext and VisualEditor, and is it better if everyone's in VisualEditor? Yes, there are some edge cases where using VisualEditor will bail you to wikitext. So if you have an edit conflict which can't be resolved automatically, wikitext is the way that edit conflicts get resolved currently. This is one of the reasons we're very interested in multi-user collaboration, live collaboration, real time. It is possible, if you had a wiki that was VisualEditor only, as it were, you probably have a much nicer time of things. But actually, there aren't any significant issues. There are significant issues. We coded around them. So hopefully it's okay.
So I would say to that it's clearly easier to have something like a rich text editor if you started off with everyone using that text editor, and they always have since the beginning of time. Unfortunately, our beginning of time was the 15th of January 2001, and we kind of have 20 million pages in the existing corpus.
29.
Oh, okay. Well, there you go. And that's just English Wikipedia.
Yeah.
So as a design goal, like these interactions have to be possible. Wikia has actually had some success using CK Editor or whatever it is they use now on new wikis, because instead of having a few very large wikis, they have very, very many, like tens of thousands, reasonably small wikis, and new ones pop up all the time. And so they actually have reasonable opportunities to start new wikis with a new semi-experimental environment where no one ever uses Wikitext, because they create wikis like every morning for breakfast. That's probably almost literally true.
Anyway, that's us out of time. If you have any more questions, Lyra is to talk to you down here or later. Thank you very much.